Hey guys, welcome to the video for interpreting different linear forms. We're in Unit 3B. Our essential question is, when is it more useful to use one form over the other forms? I'm going to refer back to this essential question throughout the lesson just because sometimes it is easier to use one form over the other, and sometimes it's more difficult to use one form over the other. We've been in Unit 3 for a while, and we have talked about three different forms. We've talked about point slope, slope-intercept, and standard form. These are forms of lines. So these are just different ways to write equations of lines, but they all mean the same thing, they just all look a little bit different. So let's start with point slope. Point slope form is y minus y1 equals m times x minus x1. It is called point slope form because it gives you a point and a slope. Your slope is the m. Your point is the point x1, comma, y1. And remember, the most key thing is that when you plug in the point, it's opposite signs. All right, the next thing we're going to talk about is the slope-intercept form, which is the form you learn in 8th grade. Y equals mx plus b. It's called slope-intercept form because it gives you a slope and an intercept. But more importantly, it gives you the Y-intercept. So the m is your slope, and it's always going to represent your slope. The b represents your Y-intercept. So if b was 5, then your Y-intercept would be 0, 5. All right, the last form that we learned was standard form. That's ax plus by equals c. Now this form doesn't really give us much, hence why it's called standard form. It's just the standard. Doesn't give us much, doesn't give us a slope, doesn't give us a y-intercept. It just looks kind of nice. But there are 3 requirements for standard form, right? The first requirement is that x and y are on the same side. Preferably the left side. The second requirement is that we can have no fractions or decimals. The last requirement is that we want a, your a term, which is in front of your x, you want a to be positive. Okay, moving on. So we're going to go through 2 problems here. And with number 2, it is a little bit longer just because I asked for more information, but it is essential for what you need to know. So burgers are $3 each, and Cameron bought 4 burgers and has $18 left. So the point of these notes are you being able to go from form to form. So normally, if they don't give you an equation already, you have to start in point slope form, because point slope form is the easiest form to use when they've given you very little information, because all you need is a point and a slope. It's not very specific. You just need those 2 things. Now, when you're given these problems, you have to read it, because a lot of the times they give you the information you need. You just have to be able to interpret it. They either give you 2 points or they give you a point and a slope. Now with slope, you want to look for keywords that say like per day or per hour or each day, each hour, every day, every hour. So something that's repeating a rate of change, right? Or slope is always repeating. It's going to be the same thing every single time. So as we start, I notice that it says the burgers are $3 each. Because it says each, it leads me to believe this is the slope. So our slope here is going to be 3. Well, it can't give me 2 slopes, so the other information has to be a point, right? Because you can't have 2 slopes for a line, you can only have 1 slope. Well, the other information is that you bought 4 burgers and you have $18 left. Well, that's going to be a point, but we got to figure out, is the burgers X or is the money that you have left X? Let's think about this. Does the number of burgers depend on how much money you have left? Or does the money you have left depend on the number of burgers you buy? Okay? The number of dollars or the amount of money that you have depends on how many burgers you buy. Because the more burgers you buy, it's going to change how much money you have left. So the money you have left is dependent, which means that this is your y variable. So the burgers is going to be the x variable. So when I make a point, remember it's x comma y. So in this case, be 4 comma 18. That's our point. We're given a slope and a point. Because they've already given us the slope, we don't have to find it. But we do have to start in the same form as always if they don't give us anything, which is point-slope form. Point-slope form is this, and I'm going to go ahead and copy it down just so we have it for reference. Now we want to plug in our information. Again, we don't need to find slope because they already gave it to us. So we have y minus 18 equals 3 times x minus 4. Okay, so remember your signs are opposite and make sure you plug in your slope in the correct area. Now that's point-slope form. So I have one part of my objective here. I want to find all three forms, and I found the first one. The next form is slope-intercept, y equals mx plus b. I need to get y by itself. So the first thing I'm going to do is I'm going to distribute. Y minus 18 equals 3x minus 12. Is this in slope-intercept form yet? No. First, we need to add the 18. And we want to make sure we add to like terms. You can't add to terms that aren't like. They won't combine. So y equals 3x, negative 12 plus 18 is positive 6. Is this y equals mx plus b? Yes. So I'm going to go ahead and write that down as my slope-intercept. Okay. The next problem, and I'm going to go ahead and copy this up here because I ran out of room. The next thing we need to find for is standard form. Remember, there's 3 requirements. The first requirement is that x and y need to be on the same side. So the first thing I'm going to do is I'm going to subtract 3x from both sides. So then I have negative 3x plus y, because that y is positive. If it was negative, there would have been a negative sign there, equals positive 6. Now, some people might stop here and think that this is standard form. But why is it not standard form? Well, x and y are on the same side. I don't have any fractions and any decimals, but my a is not positive. A is negative 3, so I need to turn it to positive 3. Well, the only way for my negative 3 to become positive 3 is if I multiply it by negative 1. But when I multiply, I have to multiply to every single term. So I have negative 1 times negative 3, going to be positive 3x. Negative 1 times y is just going to be negative y, or negative 1y. And then negative 1 times 6 is going to be negative 6. You can write the 1 in front of the y if you'd like, but I prefer to leave it off, and it's just a little bit more simpler and easier to see. So that's going to be our last form that we need. That's our standard there. All right, moving on. So this is when our essential question is going to kick in, especially when we get to those last 3 problems. So Samantha has ran 60 feet after 2 seconds. After 9 seconds, she runs 165 feet. So let's interpret what we have here. Do we have 2 points, or do we have a slope and a point? Okay, well, the first thing it says is that she ran 60 feet after 2 seconds. Well, that doesn't sound like a slope to me. That must be a point. Now, is it 60, 2 or 2, 60? Well, when you're thinking about this, you also have to think about, well, which one of these would be independent from the other one? Would feet be independent, or is seconds independent? And seconds is independent, so that's going to be our x, and feet is our dependent. The reason why seconds is x, because it's time, and time is always going to be your x value because it's always independent. Time doesn't depend on anything. So anytime you have seconds, hours, months, minutes, anything like that, that's always going to be independent x. So our point would be 2, 60. Then we're given 9 seconds, she ran 165 feet. Well, this isn't a slope either. So this is also another point. Because it didn't give us just one number, it didn't give us a rate of change. It didn't say each second she runs blah, blah, blah. It didn't say that. It's telling us that after 9 seconds, she's run 165 feet. So that means our second point is going to be 9, 165. But just because the 9 came first doesn't mean it's the x. It's the x because it's seconds and it's time. Okay, well, in the last problem, we were given the slope. Here, we're not given the slope, so we have to find the slope. We got to use our slope formula to find it. M equals y2 minus y1 over x2 minus x1. We're given the slope here. Well, let's go ahead and label our points. It's going to be 165 minus 60 divided by 9 minus 2. Well, then I'm left with 105 divided by 7. And that's going to give me 15 if I simplify it. So that means my slope is 15. Okay? Well, what does that mean? Does that mean she runs 15 feet a second, or does she do 15 seconds a foot? Well, how do you figure that out? Well, let's think about this. On top, what is always on top, our y or our x? it's always our y, right? Oh. Y is always on top. Well, what was y in this problem? It was feet. So when you were dividing 105 divided by 7, you were dividing 105 feet over 7 seconds. So that's going to be 15 feet per second, right? So that's what the slope means. It's 15 feet per second. Remember, y is always on top. So that's going to help you determine, is it seconds per feet or feet per second? All right, now that we have the slope, we want to plug it into point slope form. And then you pick a point, and it doesn't matter which point you pick. I'm going to pick the first one. So it would be y minus 60 equals 15 times x minus 2, point slope form. The next thing you're going to do is you're going to distribute. Actually, let's go ahead and write our point slope form down because we have it. We're going to distribute now. Y minus 60 equals 15x minus 30. Next step is add 30 to both sides because we want slope-intercept form. Y equals 15x. Oops, you know what I messed up on? I'm not supposed to add 30. Why am I supposed to not add 30? Well, I'm trying to get the y by itself, so I should be adding 60. That's my bad. I didn't realize my mistake. There we go. Y equals 15x plus 30. That's slope-intercept form. Okay, I'm going to go up here because I ran out of room. Okay, the next one we want is standard form. So we need to get the x on the left side because we need them to be together. Well, this is almost standard form. However, you can't have a be negative. So you got to get rid of that negative. To make negative 15 positive 15, you want to multiply everything by negative 1. Negative 1 times negative 15 is positive 15. Negative 1 times y is just negative y. And negative 1 times 30 is negative 30. So this is our standard form. And again, if I were to graph all of these three equations into a Desmos or into my graphing calculator, they're all going to be the same exact graph. They just look different when you write them out in form, but they're all the same. All right, so here's when we go into the central question of when is it more useful to use some forms over other forms? So the first question is, what is the slope and what does it represent? Well, there's two forms out of the three that I have that give me a slope. So let's see. Does point slope form give me slope? Yes. Does slope-intercept form give me slope? Yes, it's in the name. It says slope. Does standard form give me slope? No. So when I'm asked to find the slope, you don't want to go to standard form because standard form isn't going to help you. It just makes it more tough because you can't actually see the slope. So if it's asking for slope, look at a form that gives you the slope. Let's pick the second one. What's the slope of this equation? 15. And it's also 15 in the other form as well. But what does that mean? Well, 15 represents how fast she's going each second, right? So it represents the number of feet she runs each second. Now, how did I figure this out? How did I know that? Well, remember we talked about it at the very beginning. Feet over second. So it's going to be feet per second. She goes 15 feet for each second. That's what the slope represents. All right. What is the x-intercept and what does it mean? Well, do any of these forms give me an x-intercept? None of them give me an x-intercept. Two of them give me a slope. One of them gives me a point. Another one gives me a y-intercept. But I don't get an x-intercept from any of these. So normally when we are asked to find x-intercepts and y-intercepts, we typically like to use standard forms. So let's go ahead and pick our standard form equation for this. So this is the one I want to use. 15x minus y equals negative 30. Well, how do I know what an x-intercept looks like? Well, the x-intercept looks like number comma 0, right? That's what the point looks like. So where would you plug in a 0? For the x or for the y? You would plug it in for y because the 0 is in the y value place. So you would have 15x minus 0 equals negative 30. You're replacing y with 0 because you have a 0 in for it. We're trying to find the x-intercept. Well, that's just going to cancel. So you have 15x equals negative 30. And we want to solve for our x because we're trying to find our x-intercept. So you divide both sides by 15, and you get x equals negative 2. So what is your x-intercept? Negative 2 comma 0. Now what does it mean? So we have to go back to the very beginning to talk about what does it mean. because we got to figure out what x represents and what y represents. Well, x represents the seconds, and y represents the feet. So let's go look. It's saying that at -2 seconds, you're at 0 feet, which doesn't really make any sense because you can't really have negative seconds, right? You can't have negative time. So what does it really mean? There's no real meaning here. Now, sometimes it will have a real meaning. So if your x-intercept, for example, just a random example, if it was like 8, 0, that means that at 8 seconds, she's at 0 feet. That makes sense because you can have 8 seconds, but you can't have -2 seconds. There is no real meaning here. Okay, so -2 seconds and 0 feet doesn't really make sense. What's the y-intercept? Again, you want to use standard form or maybe slope-intercept form. So there's 2 ways you could do this problem, and I'll show you the first way. The first way is to find this y-intercept by using your equation again. 15x minus y equals -30. Well, a y-intercept looks like 0, number. I would plug in a 0 for my x value. So 15 times 0 minus y equals -3. Well, 15 times 0 is just 0, so that cancels. I have -y equals -30. Is the y by itself? Technically, no, because it has a -1 in front. So you need to divide both sides by -1 and get y equals +30. So what is my y-intercept? My y-intercept is 0, 30. But I'll actually show you something. So you could have found it using standard form. But which one of these forms gives you a y-intercept? Does point-slope form give you a y-intercept? No, it gives me a point and a slope. Does slope-intercept form give me a y-intercept? Yes, it gives me a slope and a y-intercept. What is the y-intercept? It is 30. Isn't that what we just got? So again, using some forms can be more useful than using other forms, but it's whether you see that easiness or not. And if you don't, then you have to do the work for it. So what does this mean? Well, remember, x represents our seconds, our time, and y represents our feet, or our distance. So this is saying that at 0 seconds, at 0 seconds, 30 feet. What does that mean? Well, remember, a y-intercept is your starting value. So that means that she started, because she started at the very beginning, which means no time has gone by. So she started at 30 feet when she started running. When she started running at 30 feet. So at 0 time, so she hasn't started, she's at 30 feet. She starts there. She starts early, she starts 30 feet ahead already. So again, this is going to be one of those things that it does take some time to get used to, and it is more of just problem solving and can you figure out an easier way to do this, and also which form is the best form to look at when I'm trying to get some information from it. If you have any questions, please feel free to come in for tutoring.